What we're going to do today is just practice what we had done on Monday and Tuesday, which was regressions. Let me just better explain what a regression is, because a few of you have messaged me that you're a little bit confused. What a regression is it's given a whole bunch of data points and it tries to predict what's going to happen then in future situations. So, for example, if you make note that, let's say January 1st, it's this many degrees. January 2nd, it's this many degrees. And you see that the temperature, let's say it's slowly going down, right? Let's say it's dropping because typically you get colder, I guess, as you get closer to February. So if you're given some degree measures in the beginning of the month, you can then use that to predict what's going to happen at the end of the month. Okay, it's kind of like a line of best fit. So, for example, if I have, you don't have to write this, but let's say I have all of these separate data points happening here, 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 and you see that using this curve here best represents what's happening. It's not going to be exact because, again, it's never going to be exact. It's never going to be exactly the case. It's just giving you what is approximately happening. This is also kind of like what's going on even in the news. If you watch the briefing that Governor Cuomo does, for example, you'll see, well, maybe a few weeks ago when they were trying to predict what was going to happen, you'll see that they gave you this curve, and then they predicted what the curve would be as it flattened. Okay, so it's not going to be an exact science that this is able to do. It's just going to give you an approximation of what's going to happen. Okay, so if we look, let's look then. We'll just go to the example. For number 1, a rapidly growing bacterium has been discovered. Its growth rate is shown in the chart below. Write the exponential regression equation modeling this number of bacteria, and we're rounding to the nearest thousandth. So that's your first question. You're going to stop and answer that question. In your calculator, you're going to press Stat and then Edit. You're going to clear out anything that you had. So you're going to go up to list 1 and list 2, press Clear, and then press the down arrow, and it'll clear it out. So for your X values, you're going to type in the hours since the observation began. So you're going to go right down the list, 0, 1, 2, 3, 4, 5. Then you're going to go over to list 2. You're going to type in 20, 40, 75, 150, 290, and so on and so forth. Once you do that, you're then going to press Stat, go over to Calc. This is asking you for an exponential regression. So you slide your cursor down until you see EXP regression, EXP-REG, which is choice 0. You press Enter. Your X list is from list 1, meaning that your X's you typed into list 1, your Y's you typed into list 2, press Enter, and then you just keep pressing Enter until it says Calculate. If it says invalid domain, you might have typed it into an empty list. So for example, if you typed it into list 3 or list 4 and you're telling the calculator to calculate on list 1 and list 2, just make sure it matches. So that might be the invalid dim thing. And then you press Enter, and then it'll give you everything. So I'm going to pause now. You can pause the video if you want. I'm going to write out everything that I see on the calculator screen, okay? Okay, so this is everything that your calculator screen gives you. Now the question asks you to round to the nearest thousandth. So you're going to take this information and plug it in. You're going to actually plug in A and B because that's what your equation's going to use, right? Use A and B. And then you round where it's telling you to round. You really, the R squared and the R, the correlation coefficient, you just need to write that down for your work. The question, it doesn't really have anything to do with R squared and R. Okay, you just need to know that the closer that it is to 1, the more accurate your curve is. It's never going to be 1, again, because it's never going to be exactly the correct curve. It's never going to tell you exactly the future. It's just going to estimate. So your answer, we're rounding to the nearest thousandth, that's 3 decimals, is y equals, A is 20.5122. I'm sorry, 20.512. times b is 1.924 raised to the x power. And that's it for the first question. The second question is to use the equation and determine after how many hours there's going to be 2,500 bacteria present. So using this model, predict how long it's going to take for there to be 2,500 bacteria. Is it going to be exact? No, it's just a prediction. Okay, but it's an accurate prediction because your correlation coefficient is pretty close to 1. So you are solving for the time, which is the x variable, right, the hours since the observation began, and we want y to be 2,500. So again, this is your answer to the first part, just the equation. So once we have that, we know 2,500 equals 20.512 times 1.924 raised to the x power. Your variable's up in the exponent, so you need to use logs to solve. You divide both sides by 20.512. On the right side, you get 1.924 raised to the x power. On the left side, you get 121.8798 98752. And that's from doing 2,500 divided by 20.512. So now the point to doing this is that you can now use log. So take the log of both sides. So log of 121.8798,752 equals, the variable comes to the front, the exponent comes to the front, x log 1.924. Divide both sides by the log of 1.924. Over here it'll cancel, so I get x equals, on the left side we're rounding this to the nearest hundredth of an hour, 7.34 hours. Okay, the only real new part is finding the equation. You already knew how to solve exponential word problems. It's now just being put in a different context. Okay, so the new part is really just finding the equation, and then they can ask you another question, but it has to be based off of something that we already did. Okay, number 2. So 2 and 3 are a little bit different. Okay, number 1, that was an exponential. That's what we did on Monday and Tuesday. Number 2, if you go through and read, it tells you to find the sinusoidal regression. Sinusoidal, that's a trig function. Okay, so for right now, though, everything stays the same. So write the equation. What are we even talking about here, actually? We're talking about the monthly temperature in Chicago, and we're talking about January to December. So write the equation of the sinusoidal regression that best models the monthly temperature in degrees Fahrenheit, where x equals 1 corresponds to January. So the month number is the x number, obviously, because you can't type in to list 1 January, February, March. So you're going to type in 1, 2, 3, 4, 5, and all of the month numbers, which it goes 1 through 12. Okay, so in your calculator, you're going to press Stat, Edit. You're going to go up and clear list 1, go up, clear list 2, and then you can go to type in. So for list 1, you're going to type in 1 through 12. For list 2, you're going to type in all the temperatures, so 21.2, 25.7, so on and so forth. When that's done, you're going to press Stat, Calc, and then you're going to find the regression. We're looking for sinusoidal regression. That, it says sin reg, sine reg, which is choice C. Okay, so you press enter on that. It says iterations, that doesn't matter. Your X list is whatever you typed into, so I typed into list 1, that's what I explained to you guys. Y list is list 2. Ignore the period, ignore the the regression equation, just press calculate, and it'll list everything out for you. I'm going to pause again, write down everything I see on my calculator screen. You're going to do the same thing, make sure it matches mine. Okay, so this is everything you see on your calculator screen. If you see this is going to be your equation, the top thing is your equation, and then underneath has all the variables that you're going to type in. Okay, so if you see here, you have y equals a is 26 point blah, blah, blah. You round that number to whatever it's supposed to be. Sine of b is 0.48, blah, blah, blah. X, and then you have minus 1.87, whatever you're rounding to, plus d. Okay, this one, it doesn't give you r squared and r. The reason why is because it has a whole bunch of variables in it. Not a big deal. You just write down what you see on your screen, round it correctly. So this would be our variables here. It says that your y value, the temperature, to call it F. I mean, that also can be a little confusing though, because that just looks like it's saying it's Fahrenheit. So if you write y equals, it's not a big deal. But I'm gonna have, instead of y, we have F equals a. We're rounding to the nearest. What does it say? Thousandth. So 3 decimals, so we have 26.414. Sine of B is 0.481. X plus C is negative 1.878 rounded. And then plus D is plus 46.804. And that's it. That's the equation. So now using this, the question then says, what is the range of temperatures in Chicago? So now this makes sense because it's periodic. You're going up and down, up and down, up and down. So the range is the min and the max. If you remember, to find the min of a trig function, you take the midline, which is the number that you're adding or subtracting. So in this case, it's 46.804. That's all the way on the right. To find the min, you take the midline and you subtract the amplitude, which is the number out front, 26.414. To find the max, you do the same thing, but instead of subtracting the amplitude, you add the amplitude. 46.804 plus 26.414. We started this like real world trig stuff right as the whole COVID thing hit. So I think one of the last things that we did was putting it in a real world context. So we were going to continue on with that the following week. So if you're still a little fuzzy, then that's going to be why, okay? Your min, if you actually subtract those, we're rounding to the nearest hundredth. Your min is 20.39, and your max is 73.22. So if you want, you can actually write this as a range. So 20.39 to 73.22. And that is the range, meaning that the minimum temperature is 20.39 degrees, maximum temperature is 73.22 degrees in Chicago, Illinois. And last one. Accompanying table shows wind speed and the corresponding wind chill factor when the air temperature is 10 degrees Fahrenheit. So what this chart means is if it's 10 degrees Fahrenheit and your wind speed is 4 miles per hour, it'll feel like 3 degrees Fahrenheit instead of the 10 degrees Fahrenheit, okay? Write a logarithmic regression equation. So same idea, you're just choosing a different button when you go to calculate, okay? So in your calculator, we're rounding to the nearest 10,000th, which is 4 decimals. In your calculator, you press Stat, Edit. Again, you clear, do not delete. Do not delete. Clear list 1, list 2. You're going to type in the wind speed as your X and the wind chill factor as your Y. And then you press Stat again, Calc, and then you're going to scroll down. You're not going to choose LIN. LIN is linear. LN is logarithmic. Okay, so if you keep scrolling, I think it's actually like the second. Oh no, that was fine. It's choice 9. LNREG, logarithmic regression. LN is a natural log. Okay, you're not going to do a common log for these. Do not choose logistic. Logistic is something different. That's not logarithmic. All right, so you're going to write down everything you see on your calculator screen when you're done. Okay, so that's everything you see on your calculator screen. Now you're going to take that equation that it gives you, and you're going to plug in your variables for A and B, and you're rounding to the nearest 10,000th, which is 4 decimals. So the equation that represents this chart is y equals A is 13.0134 plus B, so it's actually minus because B is negative, 7.3135 ln x. Okay, that's it. So what this means is if you were to take this chart as coordinates and plot it, it would look something similar to what this equation is if you were to graph that equation in, say, y equals. Okay? Second question says, using this equation, find the wind chill factor, which is your y variable. So find y when the wind speed, or your x, is 50 miles per hour. So what is y when x is 50? So this is the answer to the first question, the equation. The second question, it just wants you to take this equation, plug in 50, and what would the wind chill factor be? So you have y equals 13.0134 minus 7.3135 times the ln of 50. There's no fancy work here to do for this. You can type that right into the calculator. And if that gives you negative 15.9 something something something, we're rounding to the nearest degree. So that would be negative 16 degrees Fahrenheit as your answer to the second question here. Okay? If you have any questions, let me know. Your homework tomorrow is going to be pretty much the same thing that you did on Tuesday. Okay? And then test on Friday like always. Have a good day.